Welcome to The Explainer. Okay, let's just dive right into this, because today we are conducting a massive, highly technical system audit on, well, reality itself. We're looking at the Jphpai Deluxe System Specification. And look, this isn't sci-fi magic. This is a rigorous framework that treats the quantum multiverse as a literal software architecture. Our main goal today is simple. We want to explain it all, break it down, and confirm if the underlying logic actually holds up. We're going to stress test this spec to see if its math can seamlessly resolve the biggest anomalies in quantum physics without crashing.
So here is our roadmap for the audit today. First, historical system errors. Second, the three grand paradoxes. Third, the layer 0 architecture. Fourth, quantum computing as hardware. And finally, quantum immortality and ethics. Let's get to it.
Section 1. Historical System Errors, Auditing the Ancestors. To really understand the specification, we first need to debug some old code. We have to look at the compilation errors made by the original pioneers of quantum mechanics. These were brilliant minds, obviously, but they often forced the math to break rather than just accepting the logical implications of quantum linearity. Back in 1927, Niels Bohr introduced the Bohr cut. He basically hard-coded this unconditioned if statement right into the universe, claiming the rules just arbitrarily switch from quantum to classical simply because we measure something. Then in 1932, John von Neumann rolled out Process 1, which was this mathematical patch that completely broke time reversibility by claiming particles make these sudden, stochastic leaps. Fast forward to 1935, and Einstein falsely clung to local 3D space with his paradox, refusing to accept that reality's determinism is actually global, not local. And then finally, in 1973, Bryce DeWitt popularized the many worlds theory, but he did it with a massive conceptual bug.
Let's explicitly check the logic of that traditional many worlds interpretation. DeWitt basically described the universe as physically duplicating its matter every single time a quantum event happens. But logically, that breaks the whole system. Duplicating the entire physical universe would totally violate the law of energy conservation. You'd literally need infinite mass just springing out of nowhere. No way. The JHP framework fixes this fatal bug with something called amplitude fragmentation. There is absolutely no physical duplication going on. Instead, it's a deterministic re-indexing of probability within the vast, multi-dimensional geometry of Hilbert space. Energy is perfectly conserved.
Moving on to Section 2, the three grand paradoxes. Now these three paradoxes serve as our ultimate logical stress tests. First up, the measure or Born rule problem. Think about it. If all possible quantum outcomes actually happen across different branches, how can an event have a 90% probability versus a 10% probability? If both happen 100% of the time in their own branches, where on Earth do those percentages come from? Second, we have the preferred basis problem. Why does reality split into stable, normal 3D objects, like the chair you're sitting in, rather than just chaotic, incomprehensible soups of energy? And third, the falsification problem. If we literally can't interact with these parallel branches, how is this rigorous science and not just late-night philosophy? The JFPS specification has to flawlessly resolve every single one of these to be mathematically sound.
Which brings us to Section 3, Layer 0 Architecture, the JPHP solution. Okay, this right here is the absolute core of our logical audit. The JHP framework announces a really bold fix. It solves these calculation blockers by treating reality not as physical, mechanical objects bumping around, but as a continuous unitary algorithm executing in what it calls Layer 0, or the primary Hilbert space. To follow the logic of this explainer, we basically have to throw out the concept of a single physical 3D timeline. Just abandon it entirely. Think of Layer 0 as this global mathematical matrix where the universe runs as a continuous algorithm. The 3D world we're seeing, that's just the localized user interface.
The crucial point here is captured so beautifully in Axiom I. Matter is not created, it is re-indexed. Let's test the logic on this. In the JPHP framework, the global system state vector is a constant. It always equals exactly 1. And what that means is the universe never physically duplicates its mass. You do not get two literal physical Earths popping into existence.
Let's break down the actual mechanics of this amplitude fragmentation step by step. Step 1. A quantum measurement occurs. Step 2. Instead of reality breaking or physically splitting, the state vector just simply rotates within the vector space of layer 0. In step 3, the amplitude distributes into orthogonal branches. Think of orthogonal here as just mutually exclusive, non-interfering pathways. These amplitude coefficients, remember those 90% and 10% numbers we just talked about, they dictate the phase density, or the mathematical thickness of a pathway.
They don't create a physical clone. It is a reallocation of a single constant unit of reality. The logic here is just incredibly airtight.
So let's look at axiom 2, which tackles that second paradox, the preferred basis problem. This is a brilliant fix. Why does our world look like solid 3D objects instead of a chaotic blur? Well, Jphpai introduces axiom 2 as the environmental stability algorithm. The formal name for this is einselection, or environment-induced superselection.
Here's how it works. The environment, and by that I mean the air molecules, background photons, the cosmic radiation all around us, it acts as this massive, continuous measuring device. Because electromagnetic and gravitational forces decay with distance, specifically, they follow the 1/r² law, 3D spatial position becomes the only variable that mathematically commutes or securely locks in with the environment's Hamiltonian. In simple terms, the universe calculates and completely suppresses non-spatial superpositions in roughly 10 to the power of -23 seconds. It's wildly fast. The world seems like a stable 3D place because the environment is constantly filtering it to be exactly that.
All right, time to audit the solution to the Born rule with axiom 3, self-localization uncertainty. If every outcome happens, why do we experience probabilities at all? The logic shifts brilliantly here. Probability in the Jphpai model is not some physical property of the particles themselves. Actually, scratch that, it's completely subjective. It's a subjective property of a conscious agent experiencing the system.
Let's trace the logical flow of quantum decision theory step by step. Step 1. Pre-split. You are an intact agent and you're about to observe an event. Step 2. Post-split. The event has happened, the branches have fragmented, and there are now two versions of you. But crucially, neither version has looked at the measurement device yet. Then comes step 3. Self-localization. You, the observer, do not yet know which amplitude branch, the thick 90% pathway or the thin 10% pathway you currently inhabit. Therefore, a rational agent mathematically has to bet based on the geometric weight of their branches to maximize utility across their future selves. The probability isn't the universe rolling dice, it's literally you betting on where you've just been indexed.
Okay, section 4, quantum computing as hardware. We're transitioning now from abstract math into practical, real-world application. Take Shor's algorithm, for example, which is used to crack complex cryptography. Cracking a 2048-bit RSA key, that isn't happening by some stochastic magic trick in one single universe. The JPIP logic confirms that a quantum computer is literally channeling logical processing resources across the entire Hilbert space spectrum. It pushes parallel computation threads across multiple mutually exclusive branches of reality, does the math simultaneously, and unifies the results via constructive phase interference right before thermal decoherence can shut the window. It's not just theory, it is physical proof of the multiverse architecture in action.
And now, Section 5, Existential Implications and Execution Threats.
If this airtight, deterministic math is true, and our logical audit so far really shows that the equations balance flawlessly, there are intense philosophical and biological consequences regarding what happens to a conscious agent during a critical life-or-death quantum trigger event. So, what are the odds of your consciousness surviving? 100%. I know, that is a startling number. But the system specification reveals that because a physical agent can only experience a state where their neural processing is actually functional, their subjective probability of surviving any quantum death event is absolute.
This concept is known as quantum immortality. Imagine a quantum event that triggers a lethal outcome. The amplitude splits. First, you have the lethal branch. In this index, the local execution thread simply stops, and consciousness ceases to register data. But then you have the survival branch. Over here, the execution thread remains active. Because you can only experience the branch where you're actually capable of processing data, your consciousness is forced to keep registering the temporal flow in the survival branch.
Which leads to this profound and frankly kind of chilling quote from the spec. The universe will seem to conspire infinitely to keep the execution line of your consciousness active. From your internal perspective as the observer, you will logically experience extreme coincidences, biological miracles, or really bizarre mechanical trigger failures. Why? It's not because of divine intervention. It's because it is a mathematical certainty required to maintain data persistence in layer 0. The math dictates you will always find yourself in the branch where your code is still compiling.
So, you might be wondering, does this deterministic branching reality mean nothing? Absolutely not. The ethics of the tree, or multi-route responsibility, completely counters that assumption, throwing nihilism right out the window.
The logic confirms that every time you make a decision that bifurcates the amplitude, you are generating real, conscious beings who will tangibly suffer or prosper in their local, reindexed experience. Your role as an architect in this system is to maximize the amplitude of well-being across all branches, not just the single one you happen to be locally experiencing right now.
This audit confirms it. The logic of the JPHP framework is internally consistent, mathematically robust, and beautifully deterministic. So I'm going to leave you with this final, provocative thought to apply to your own existential reality. How do your daily choices change knowing you are maximizing well-being across a deterministic, multi-root matrix, rather than just fumbling through a single, random classical timeline? Think about it. Thanks for joining me on this explainer, and keep questioning the architecture.